Next, I want to look at a triangle where we know all three sides. So SSS, side, side, side triangle. So here, I just drew a quick triangle. We're going to look at a triangle with sides 6, 9, and 4. This is definitely not drawn to scale. I just kind of try to draw a quick picture. Side A is sort of a middle length, B is the longest length right at 9, and then C is actually the shortest at 4. So again, my picture is not to scale, but it's just something to help me get organized and keep everything in order. So how do you deal with side, side, side triangles? Well, the first thing you're going to do, so the first step here, is you're going to use the law of cosines to find the angle opposite the longest side. So in this case, my longest side is 9, right? 9 is the biggest, and the angle across from that is B. So that's the one I'm going to focus on first. Now, what I'm going to do is I'm going to go back to my formula, and I want to find angle B. So I choose the formula that contains angle B right there. So I'm going to choose the middle version of the law of cosines to solve. So let's write that down. And then I'm just going to start plugging everything in. So here, let's see, I have B is 9, so 9 squared. A is 6. C is 4. It's 9 and 4. Okay. Just making sure I have all my numbers correct. So 6, 4, and then cosine of. So I have 81 equals 36 plus 16. And now 6 times 4 is 24 times 2 is 48. I'm going to add these two together here. I get 52. I'm just solving for cosine B here because that's what I'm trying to figure out is what's my angle. So I subtract 52 from both sides, I get 29. And then I divide by negative 48 on both sides. So I have that cosine of B is equal to 29 over negative 48. Now I do want to go ahead and find this angle, and I'm going to use my inverse. So I'm going to use cosine inverse. But remember before we were doing the inverse of the positive version instead. So I'm going to go ahead and do that here. And just figure out what the inverse of 29 over 48 is to start. So when I do that, I get about 52.8. So I'm going to round this to about 53 degrees. We're not done though. Remember that cosine was actually negative. So cosine is negative. And cosine is always negative in the second and third quadrants. Now, what happens here though, is if you think of a triangle, the angles add up to 180 degrees. So the third quadrant is going to be too big for an angle because the third quadrant is between 180 and 270. So you don't have to worry about the third quadrant here, just the second quadrant in this case. And I can go ahead and find that by subtracting with 180. So my first angle is going to be 127 degrees. So again, just be careful with your sines and cosines and things. Just make sure, if it's negative, keep that in mind that for cosine, you're going to be in the second quadrant instead. All right, so my second step is I still have to find two angles, and you can actually find either angle next. It doesn't matter. So you're going to use the law of sines to find either of the two remaining acute angles. Now, the last two angles will be acute. If you have an oblique triangle, either all three angles are acute or one is obtuse and two are acute. Because we specifically focus on the longest side, well, the longest side is across from the longest angle. So that's the only one that could potentially be obtuse. It doesn't have to be, but it could. Here it was. So if you have the longest side already, and then you find the longest angle, then the remaining two angles have to be smaller, so they're going to be acute angles. It doesn't matter which one you find next. So I do have to use my sine B information here because that's the only ratio that I have that's complete. And then I can use either one. I'll just choose A, just to kind of keep it in order. So for B, it would be 9 over sine of 127 degrees equals 6 over sine of A. Now remember, as you're multiplying, we're solving here, we're going to multiply both sides by sine of A, and then we're going to multiply by the reciprocal to solve. I'll save us the work. We've seen this quite a few times at this point in our last few videos. So we're just solving for sine A here. You can also cross multiply, that works too, as a starting step. And then you're going to end up with 6 times sine of 127 over 9. You're going to put that into your calculator as usual, like we have been doing, and you get about 0.5324. Now, again, remember that you're looking for the inverse of that on your calculator. Oops, that's a 3. And when you do that, you get about 32 degrees. Now, sine is positive here. So the first quadrant works. We also know that the two other angles have to be acute because they are smaller than the large angle. So you don't have to worry about checking the other quadrants here, even though sine is positive elsewhere, right? But just the first quadrant is going to be relative. So that 32 degrees is fine. And then your last step is just going to be the final angle. So we have that angle A is 32 degrees. So I know that 32 degrees plus 127 degrees plus whatever angle C is going to be 180 degrees. Well, 32 plus 180, sorry, 32 plus 127, excuse me on that one, is going to be, let's see, what, 159 degrees. I subtract that from both sides and I get that C is 21 degrees. Again, it is approximately 21 degrees because we've rounded our sine value. So our angle was rounded there, but we're able to complete the final angle. And this would be the final result in this case for this problem. So for side, you start with the law of cosines again, working with the longest side first, and then you move on to the law of sines.